The next planet is indeed my favorite, and indeed our home, planet Earth, and represents the evolution of the planet past Venus to form one of the most beautiful planets in the solar system. In doing research for this book, I went through many books, one of them being the Bible, and I had the good fortune to read many things: Vedic verses, Mormon Bible, the I Ching, and many other texts, including many great scientific works. But what struck me, and what struck me interestingly in this book, in this chapter, is the next verse that I will read to you, which goes like this: "And I saw a new heaven and a new earth. For the first heaven and the first earth had passed away, and there was no more sea." This is Revelation chapter 21, verses 1. It struck me as odd at that particular time when I was writing about that particular planet that I would get that particular reading in a normal sense in Revelations, which I never really read, and it just came. So the interesting thing about this is an understanding of exactly what does that mean. How did that get into the Bible? And if you read Genesis and you read the first chapter of Genesis, you will see the first chapter really indicates the first phase of evolution, which is the Mercury, the development of Mercury. And so I started to look at correlations in ancient symbols and ancient symbolism. And in my book, I highlighted that, and it's too numerous to mention here. But essentially, you would get a clear idea of it as we progress, and as you understand exactly what the process is of the revealing of this process of evolution of planets. Earth is in particular a very interesting planet because it represents a planet of equilibrium. And the term that I use to describe this stage of planetary evolution is the generative stage, the stage of generation of many things, in particular of life. The beginnings of the planets started with the reduction of the temperature, as we explained in Venus, and which went from 600 degrees centigrade to below 100 degrees centigrade until it has gotten to our current temperature of 30 degrees centigrade, which allows our life forms to exist. But before that, there were many other life forms, and these life forms, such as Robusco, which was a 1.5 bipolar carbon molecule, which actually fixes oxygen, which means that it combines with oxygen to form glucose. So it actually creates what we would call our sugars, our carbohydrates. And that enzyme was the first enzyme, and actually did not need sunlight for it to grow. You can look at it, it's called Robusco. It is my understanding, and from my research, I realized that it got its energy from radiation of the earth, the heat of the earth. So you would have photosynthesis, which would be the process by which plants fix sunlight in order to gain energy. And then you'd have thermosynthesis, which is the process by which enzymes such as Robusco fixed the heat in order to produce the level of glucose that was needed. In looking at the development of the planet, one has to be very conscious of time. And this time is a very interesting thing, not only because of the understanding of its relevance, but as a result of its importance in us being able to understand how long we've been on the planet and how much time we have remaining on the planet. This is very critical, how much time we have remaining on the planet. And I don't want to sound like Noah to say, well, let's get into the ark, but it's literally as serious as that. If you look at the decay of uranium, taking 4.6 billion years, you will find that on planet Earth there are remains of uranium, but in small quantities. The source of the uranium I believe to be more or less the magma regurgitating uranium that would have been in the center of the Earth from Mercury's time. So let us look at the process of aging the Earth and deciding how long we have been here. This chapter I dealt with that because I found it to be very relevant in understanding exactly how the world or the time frames in which the planets evolve. So let us take the first step. For us to find trace quantities of uranium, it means that the planet Mercury would have been almost 100% decayed, which means that almost all of the uranium on Mercury would have had to be decayed to a point of just trace elements. It means that that would have evolved after 4.6 billion years, which means that basically the first planet to Earth would be 4.6 billion years to start. If you then look at the basic small levels of plant life that have been recorded by man using a process called carbon dating, where it can be used to estimate the time frame that carbon-14 denatures. It means that carbon depreciates or carbon changes as time passes, and it is possible to measure the changes in the carbon and calculate the time which has passed. Because of this, scientists have found plant life or carbon in quantities that indicate to them that basically these plants had been around for approximately 3.8 to 4 billion years. This created a situation where we have found that if the planet has carbon of 4.6 billion years, it means that you have an issue where the uranium would have had decayed to 4.6 billion years, and there are plants which after carbon was formed have existed for approximately 4 billion years more, which means that in total, if you add generally 4 billion years to 4.6 billion years, you'd find yourself looking at about 8.6 billion years, or about 9 billion years. This means that in total, the Earth would have existed 9.6 billion years after the creation of Mercury. And if we say that the Sun ejects a planet every 3 billion years, then it means that would be 8.6 billion years plus 3 billion years, which would mean that would be 9 plus 3, which would mean that it would be almost 12 billion years that the Earth has existed. The universe is said, or our solar system is said by many scientists, to be 13 billion years old. And this, of course, you can see, has been proven not to be true. Because for that to be true, it would mean that all the planets would have had to be formed the same time, and there would be no evolution, which is obvious. The key here is, having found that the Earth is at that age, is to understand exactly why we have made that error. But the key to this is to understand not only the process of thinking, but to understand exactly why we have come about and have made those choices we have made as far as time is concerned. One of the key areas of examination is to look at the process that is going on as we speak, global warming. And to discuss this would be to raise a few hornets' nests, but it's necessary. Question arises: would global warming have still occurred to allow the evolution of the planet had we not been on this planet? And this is a serious component to this question, because I believe that whether or not human beings had protected the environment, whether or not they had made changes, whether or not we had prevented ourselves from doing whatever conservative areas that we try to conserve, there would have still been a situation where the polar ice caps would have melted from global warming, and the carbon dioxide levels would have increased to such an extent that it would have created a position where the ozone layer would be depleted and the planet will start to heat up, because sunlight is now entering the atmosphere, and that would cause desertification, as you can see with the Sahara and many other areas, and it would eventually lead to a position where we have a difficult situation in presenting a planet that will survive more than a few million years. With this, I would like to move on to the discussion on what is happening to the planet at this point. There is, in the process of generation, a pre-generative, a generative, and a post-generative stage, which I believe each planet goes through. Pre-generative position is where the planet starts to prepare itself to sustain life, and so you have the enzymes created, etc. The generative stage is where you have a fully mature planet which begins to generate the life to create animals and plants, etc., etc., and organisms, etc. And the last stage, which is the post-generative period, it becomes where the planet can no longer sustain and the planet starts to die. One of the things we'd like to discuss is what's happening at the center of the Earth. We discussed Mercury, and we indicated that what was happening in the center of Mercury was that the fusion and fission was continuing, and that was powering the planet. After 13, almost 12 million years, the energy in the center of the planet, or should I say the series of activities, is diminishing and dwindling, and the Earth now spins on its axis compared to Venus, which is at 3.03 kilometers an hour. The Earth spins or rotates at 1,000 kilometers an hour, which means that the volcanic activity would have had to increase to an extent that it would have diminished a lot of its power over time, which means that it's becoming a situation where there is less and less activity in the center, and it's becoming more difficult to sustain the planet with the energies that are available from the sunlight and also the nutrients from the Earth. This process, I believe, is the beginning of the end, and the beginning of the end to create a situation where there is the diminishing of the ozone layer is the first stage. The superheating of the planet, the second stage. The removal of water on the surface, which is the third stage. And with the removal of water, the reduction significantly in the amount of volcanic activity or the amount of oxygen produced that would generate that stage of the planet's development. At this point, the planet begins to slow down. And because there is little activity in the center starts to solidify. And as it solidifies, it ceases to have that general rotational effect. And once the planet slows down, because of the wobble effect that it has as it moves at almost 20,000 kilometers an hour through space, it will create a situation where it shakes up the planet, thus creating destruction of the center. Once the planet stops, you have the gravitational pull reducing, therefore allowing things to leave the surface and move into outer space. So you'd find that the debris, etc., and that's over millions of years, but the debris, etc., would be leaving the planet. And what you would find is remaining is what would be the center of the planet, or the magnetic core, which we call the Earth's core, which is 10% of the size of the planet. This part of the planet, the 10% of it, will eventually evolve into a planet we call Mars, which is exactly 10%, or the size of the Earth's core, and it will be a smaller planet, principally an iron ball, and that would be the end of the planet as we know it as Earth. At this stage, the planet which we know as Venus would have advanced significantly to take on the requisite characteristics that Earth now enjoys. And so that, my dear friends, is the next step for us. That is the next habitable planet in the galaxy. So rather than us moving to Mars, which is of course a dead planet, we should start working on moving towards Venus and understanding Venus, so that we can be able to civilize that planet in order to save humanity.